Thank you for tuning in to Note to Pharm.D. My name is Kenya, and today let's review primary engineering controls. Engineering controls are devices and air handling systems that provides filter air to the compounding zone and the surrounding areas. The compounding zone would be the primary engineering control, which comprises of laminar airflow hoods, biosafety cabinets, and compounding robots, just to name a few. Secondary engineering controls would be the controlled areas surrounding your primary controlled area, such as the buffer or clean room and the anteroom. The concept of the clean room is to create clean air to prevent airborne contaminants at rest and during activity. With respect to the diagram, as you move from an unclassified area to the anteroom, buffer zone, and then the compounding zone in the PEC, also known as primary engineering control, you are moving from dirty or non controlled air to clean and then cleanest air in the PEC. ISO classification regulates acceptable cleanliness standards in the controlled areas. The three classifications typically used in sterile compounding are ISO 5, 7, and 8. ISO 5 being your cleanest and 8 being your dirtiest. They're used to determine how clean the controlled area is and should be. To note, all PECs should be ISO 5 classified, buffer rooms ISO 7, and dependent on whether you're compounding hazardous or non-hazardous drugs, the anteroom would be classified as ISO 7 or ISO 8. So I just want you guys to pause here for a second and think about which form of compounding would require a cleaner anteroom. Just comment below what you think and explain your rationale, like your why. Would it be the hazardous drugs compounding or the non-hazardous drug compounding? Now let's get into some examples of primary engineering control. So it's important to note that all contains a HEPA filter, the airflow and type of compounding that can take place within the hood is what differs. So we have here the laminar airflow workbenches. The airflow here can be horizontal or vertical, and because of the variability in airflow direction, hazardous drugs cannot be compounded here. Then we have the integrated vertical laminar flow zone. The difference here is that the airflow is only vertical. However, you still cannot compound hazardous drugs here. There are some certain requirements that need to be met before you are able to compound hazardous drugs. I can address further in a separate video. But if you look at the top, there is nowhere for the air to be exhausted outside of the building that contains the IV clean room. Next are your biosafety cabinets, and it's important to note the different types. This would determine which would best protect the compounder from hazardous fumes. Regardless of the type, all biosafety cabinets has vertical airflow. Class 2A, both cabinets recycle 70% of the room air within the cabinet and exhausts only the remaining 30%. The main difference here is the pressure. In the A1 subtype cabinet is positive pressure, whereas A2 subtype pressure is negative. In the B subtypes of Class 2 biosafety cabinets, more air is exhausted outside than the A subtypes. B1 exhausting 50% of the air, whereas B2 exhausts 100% of the air. Hence why the B2 subtype is reserved for volatile substances being compounded. Otherwise, as per the USP 800 standards, For most hazardous drugs, subtypes A2, B1, and B2 are acceptable cabinets for compounding. So there are two notable restricted access barrier systems, or also known as RABs, the CAI and the CACI. The main difference here between the two is that the CACI is a negative pressure containment isolator. For that reason, your hazardous drugs would be compounded in this isolator. You cannot compound hazardous drugs in CAI, or also known as compounding aseptic isolator. This RAB system has positive pressure, whereas the CACI has negative pressure. And then lastly, your pharmacy robots. These are another type of primary engineering control system that the airflow here can be vertical or horizontal. With robots, they're very helpful because they can decrease the manual labor for batching medications, and it also decreases the exposure to hazardous drugs. And that concludes our overview of primary engineering controls. I will be going over secondary engineering controls in a separate video. Don't forget to like, subscribe, and check back every Monday and Wednesday for new videos.